Hello and welcome, my dear grade 11 advanced math students, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you all to today's session. This session is in continuation with our last video. In this session, we are going to be covering Learning Objective 4 and we are going to be solving questions 1 to 27 from page 291. So let's get started. So before we solve these questions, I would like to give you the key concept that is going to help us in this session. So in the last video, we learned how to convert logarithmic expressions to exponential form and also exponential functions to logarithmic form. Now in today's session, we are going to be looking at natural logarithms. Until now, you've been working on common logarithms. So I want you to understand the difference between these two before we proceed with today's session. Natural logarithms are written with the notation ln and common logarithms are written with the notation log. Now here the base is e, whereas here the base is 10. Okay, so if you have ln x given, it means it is same as log log, but the base is e here and not 10. Whereas for log, the base, even if not written, if just written log x, automatically it is 10. Okay, so please understand the difference between the two and the ways in which you will identify. So if you see ln written in some question, you will identify it as natural logarithm, and if you see log written or with base 10 written, it is common logarithm. So now in this session, we are going to be working on natural logarithms and we will use the same formulas that I gave you in the last video to convert a natural logarithm into exponential form and exponential into natural logarithmic form. So let's get started. So as from the last video, when we converted the log base bx equal to y into exponential, we use the conversion factor that b to the power y is equal to x. Now this was valid for common logarithms. That one is log and it has base equal to 10. I already explained you in the last slide. Now as I told you, in this session we are going to be working with natural logarithm. So this time the base is going to be e. So let's see how this formula changes for natural logarithm. So log, the base I told you is e, x equal to y. If this is given in logarithmic form, you can convert to natural log, and here log e can be written as ln x equal to y, same way, and this will be converted in exponential form with e to the power y equal to x, and here remember for natural logarithm the base is e. Okay, so we are going to be using this conversion factor. So I want you to learn this part of the formula sheet so that you are able to solve the learning objective 4 questions very well. Let's use this to solve questions now. Let's start with question 1. Here if you see, exponential equation is given and you need to convert exponential to logarithmic form, and because you see the base e, you will know this is natural log question or base e. Okay, so let's use that. So this is exponential form given, we can convert to logarithmic form. So I can write log base e x equal to 15. So this is nothing but ln x equal to 15. So this is how you get the logarithmic form, and this is natural log. Okay, let's do similar way here. So the base here is e, so it will be log e, and then it is 45 is equal to 3x. So I can convert to natural log because the base is e here, and this is your answer. In a similar way, the final answer for the next question would be ln base e, or directly I can write, let me change this little bit, I will remove e, I can directly write ln x, and here this number is given to be 0.2 equal to minus 5x. Yes, so this is your final answer. In a similar way, let's solve question 4, 5 and 6. So again here the base is given e, all our exponential form we need to convert to natural log. So I can directly write ln 10x equal to 8.2. If you want to add one more step, then you can write log e3 x and then convert into ln form. This one again similarly ln 8x equal to, so these are the natural logarithmic form. Let's do question 7, 8, 9 in similar manner. Again, the base is e, so these are natural logarithmic questions. All are given in exponential form. We need to convert to logarithmic form. So we will write log base e x minus 3 is equal to 4. And the next step, we'll convert to natural log and write our final answer. Similarly here, ln 8 equal to x. And the last question, ln 10x equal to 5. So this is how you solve natural logarithmic question. Now let's do the opposite this time. ln is given, that means the natural log equation is given. You have to now convert this to the exponential form. So we'll do opposite of what we have done till now. So ln by definition is the natural log. It can be written in common log form as log base e. And now I convert the logarithmic equation to exponential form. So it becomes e to the power x to 50. So this is my exponential form. In a similar way, let's do this. Log E36 is 2x. So e to the power 2x is 36. Now this is the exponent form and you can see the base is e. So we are done. We are doing correct because it is natural log this time. Final answer here would be log ex equal to 20 or e to the power 20 is equal to x. So please check your answers. Let's now similarly solve these questions. If you see carefully, these are natural log questions. So we will use LOGEX. This is the first step because it is natural log, the base is E. So we are going to convert them into LOG form with the base E. I hope you're understanding how the steps are working. Now the next step would be to convert these natural log equations into exponential form. So I will use E as the base and then this number on the right comes on the top. So 8, 9.6 and x, and this is going to be equal to the number on the left side. So this is going to be x. Answer for this is going to be 4x. This is the answer for this question. And finally, for this question, this is the answer key. I hope you are understanding how this conversion is happening. Let's finish question 16, 17, 18 in this slide. The only difference is here equal to is not given. This symbol means approximately equal. It's not exactly equal. Pay attention. So again, we will use the same concept. Log ex is approximately equal to 0.3345. And now we can convert to exponent form. So e to the power 0.3345 is also approximately equal to x. I did not use equal to because it was not given in the question. For this question, I will now go directly to the answer. So e to the power x is 15. This is the exponential form for question 17. Similarly, for question 18, e to the power 2x will be equal to 5.34. That's your final answer. Now comes some important question. Whenever you see write each expression as a single logarithmic form, you know this question is to be solved using properties of logarithm, and this time we have ln given everywhere, so we are going to use the properties of natural log, means ln. So let's see how it works. Now first step, you see the numbers. Okay, so there is 3 here and this is outside, it's multiplied, so I can use property ln 3 to the power 3 minus ln 9 can be written as 3 square also. Similarly here I use ln 16 to the power 4 minus ln 256, and here I use ln x square plus ln 4 square. So this is the first step in each of these questions. What did I do? I use the power property. So this number which is outside comes in the power. Now, there was no need as such of writing this 9 as 3 square, but even if you do, it is going to be the correct answer. Now, it is subtraction in these two questions, so subtraction changes to division. So I can write ln square over square, ln 16 to the power 4 over 256, and here it is addition, so it will be just multiplied, square multiplied by this. So remember, subtraction changes to division, addition changes to multiplication. So here 3 square and 3 cube are there, so it only remains as this value. So you may just add one more step to ease for you. So 3 square cancels, only 3 is left. So ln 3 is the final answer for this. So have you written as a single logarithm? Yes, so that completes your question. Let's do this one also. So here ln 16 to the power 2, 16 to the power 2, and 256 is 16 square. So you may cancel the common term. You are left with ln 16 square, which is 256. Again, it's a single logarithm. Let's come to the last one. So ln 4 square is 16, so 16x square. This is single logarithm, or you may just add one more step, apply the power property. So 2 is in the power, it comes down. So when this 2 comes down, it gets multiplied. So 2 ln 16x. That can be your final answer. Now let's solve question 22, 23, 24 using the property of logarithm. So here you see number 3 is common, so I can take it outside and write ln 4 plus ln 3. Now if we apply the property of logarithm, multiplication changes, addition changes to multiplication. So this is ln 4 multiplied with 3. So the final answer is 3 ln 12 for question 22. Let's proceed to question 23. So here you see a negative sign with the ln. So that means it will change to division. So ln 125 divided by here. Now before we divide, we can apply property. So I can write this 2 in the power. So it will become, let's add one more step, ln this minus ln 5 square. So this is equal to ln, I will just write it in a better way. So this is going to be ln 125 minus ln 25. Now subtraction is there, we can convert to division. So ln 125 divided by 25. So it cancels, 25 5s are 125. So the final answer is ln 5. Let's do similarly, applying the properties for question 24. Now in question 24, you have numbers which are different, so you cannot take common. Let's move it to the powers. So this becomes ln 3 square plus ln 100 square. Now because it is multiplication, we can addition, we can convert it to multiplication. So this is ln 10 cube plus ln, now 10 100 square will get 4 zeros. So this is 1, 2, 3, 4. So I can write ln 3 square plus ln 10 to the power 4. Now it's easy. We convert addition to multiplication. So 10 cube multiplied with 10 4. Since the base is same, powers are different, they will get added. 3 plus 4 is 7, and now just to simplify, we can apply power rule, bring the power down, and this is your final answer. In a similar way, you can solve these questions. The final answer for question 25 will be minus 8 ln 1 by 3. For question 26, the final answer will be minus 2 ln 2. And for question 27, the final answer will be ln x to the power 8 over 625. Now I will be providing you the answer key for all the questions that we covered in today's session. Make sure you check your answers and you see how you are presenting your answers in these slides. This is how you have to show your steps, show your working. If these kind of questions come for a free response paper-based exam where you need to show all the steps. Now in the following slides, I have provided you the final answers. Please check through them. This is the answer key for all the questions 1 to 27 that were covered in today's video from page 291. So with that, we have come to the end of this session. We have completed learning objective 4 in today's session, and in this video we covered questions 1 to 27. So I hope this video was useful for you and you got the answer key for all these questions and understood the concept of simplifying expressions with natural logarithm. That's all for today's session. If you found the video useful, make sure you like, share and subscribe to the channel. Stay glued to the channel for more visual videos coming up, especially for grade 11 advanced revision. Press the bell icon so that you don't miss the notification of my upcoming videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.